So guys, before writing machine learning program, we'll see one problem statement. Okay, so the problem statement is, let's suppose there is a company called ABC Private Limited, okay, who wanted a machine learning model to predict the salaries of employee based on their salaries, so that they can offer the similar salaries to new joinees. Company has given a data set called the salary underscore data, where there are two columns, years of experience and the salary. Okay, so year of experience will be our input variable or features, and the salary would be our dependent variable or the R labels. Okay, based on this given data set, we have to write a machine learning program and implement the model. Now let's start to write the machine learning program. Go to the Jupyter notebook, open a new Python shell. First we will create a data frame object to read our data set. Okay, for that we have to import a library called pandas. Ready? So I just imported a panda. Now I'll create a data frame object, pd.read csv. Now I'll place my file .csv. We'll check the data. Yes, so the data frame is got created. Now we will do some data pre-processing activities, like we will check if there is any null data or missing data, or if there is any categorical features are available. By seeing this data set, we see there is no categorical feature. The categorical feature means the column which is having the string or character type data type, those features will be called as categorical features. And for machine learning, the machine learning models will work on the numbers. So always we have to take care of converting those categorical features into numbers. We can also see a few more things using this command called df.info. Like what are the columns it has, what are the rows it has, and what is the data type. Now to see the missing data, we have to run the following command. Okay, so df dot is null, sum. So from this command you can see there is no missing data. Okay, the year of experience and salary having a 0 missing data. Okay, now we will split this data set into the x and y variables. Okay, to get the x variable, okay, from the given data frame or data set, we have to use a command called the drop method, df dot drop. Now in x variable we have to store the years of experience column, so I have to drop the salary column here. Okay, so I'll place this. And one more argument called axis is equals to 1. 1 denotes if you wanted to drop the column, okay, then you have to give axis is equals to 1. Run this. Now check whether you have any data in the x variable or not. Yes, x is storing the years of experience values. Then similarly we will create a y variable as well. So we have created a x and y variables. Now we will try to draw these points on a graph to understand the the relation between these x and y variables. Okay, to plot a graph, we need to import the library called matplotlib and class called pyplot. From matplotlib import pyplot as plt. Now I'll draw a scatter plot. Okay, for that I have a method called scatter. The first argument will be your x value, second would be y. Okay, then you can also give the the color of your points or observations and marker. You can see these once the graph is shown. And I'll also give the labels for these x's. So x label, salary will be my y label. Okay. By this graph we can understand, the y variable, that is salary, is linearly progressing with, the x variable, that is experience, right? So from this graph we can decide, the which model has to be implemented now. So the basically with this graph we can understand, the linear regression model will be, best fit for, the given data. Now we will try to implement the linear regression model for, given data set. Before implementing a model, we have to split the given data set into, the training set and test set. So basically, what is training set? So training set is, the major portion of your given data set, say, 70 to 80% of data, which we will use to, implement the model. I will fit this training data with the model so that, the model can derive the coefficient and the intercept, or, constant values for, a linear regression model. Then after, the testing set will be used to validate the model. Now let's split this, the given data set into the training set and the test set. Okay, to split this data set, basically we have to import the library called, sklearn. It is nothing but the scikit-learn, okay, library. sklearn, nothing but the scikit-learn. Okay, it is a package which has almost all the machine learning algorithms, okay, which we can import in our machine learning program to implement the models. Now we will import scikit-learn package from sklearn dot model selection. Here we have to import the class called train test split. Okay, now here is the command to split the given data set into training set and test set. Your x, y, and what would be your test size? So I'll take as a 20%, and the another argument would be random state. Usually we take 0. Now we'll see what is the value of x train now. Okay, now we'll see the x test. Okay, we'll also see the length of these variables. Okay, 24. Okay, the training set will hold the 24 records, and the test set will hold the 6 rows. As now we have ready with the training set and test set, now we'll implement the model using the training set. Now to implement the linear model, okay, we have to import the package called sklearn, and the class would be your linear regression. Let's import. Okay, now create a model object, simple linear regression model. So I have created a model object. Now I'll have to train this model. Okay, to train this model I have a method called fit, and I will pass our training set so that the model can train itself and derive the coefficient and the intercept or the constant values. Okay, so model underscore slr dot fit. You have to give your training set arguments. Okay, so the model is trained now. As model is already been trained, now if you want, you can check the coefficient and the intercept values. To see the coefficient, we have a command called this is for a coefficient. Similarly, to find the intercept, we have a command called, okay. So now my model is ready. Now we'll try to to validate the model, okay. As we already have a test data, right, ready, so we'll perform the validation on the given test set. To validate or to predict the the test set, we have to use a method called predict, okay. Model slr dot predict. Then we have to pass one argument, that is your x test. Okay, so these are my predicted values. Now we'll see our actual values so that we could compare. So I have my actual values in y test variable. Okay, now we can compare, and this with this with this. So my predicted values are very close to my actual values. Okay. Now we will see what is the accuracy of our model. To find the accuracy of our model, we have a method called score. Okay. So here we have to pass two arguments. First one is your x test. The second one would be your y test. Okay. Okay. So the accuracy of my model is 98%. That is pretty good, it seems. So guys, these are the steps which includes while implementing the machine learning model. Once your model is ready, you can save this model into the pickle file, and that file can be deployed into your production server. We will see how to save the model file. Before that, we will see how to predict the individual values. Okay. Model score SLR and predict in bracket. Let's suppose if you wanted to see the the salary for year of experience of 2, okay, then here is the value. So the expected salaries was be the 45,405. Now we will also see what is the best fit line the model has drawn. Okay. To see the best fit line, again we have to use the library called matplotlib. Okay, I'll just copy the the existing code, and I'll do some minor changes on that. Okay, so this is our blue line, which is best fit line for our given data set. Now we will see how to save model. Okay, to save the model, we have to use a library called pickle. Okay, now I have to create a file to save this model. Okay, file name is equals to, now here is the command to save the model, pickle.dump. So once you execute this, okay, the model file will be saved, okay, in your machine directory. So you can see now this is the file. Okay, it won't have the big size. Okay, it will be in a binary format. Okay. Now, so once it gets created in your machine, you can deploy this file into production. Once your model file is deployed in the server, okay, following command can be used in the production server to read the model file and initialize the model. Okay. Now the model is got initialized. Okay, now we can predict again with this model variable. Okay. Okay, so this is the way to save your model and deploy into your server. So guys, that's all for today's session. If you like my video, please click on like button and subscribe my channel.